In this section, we'll build on what we learned about in section 2.2 and learn several more properties about functions and their graphs. We'll start with increasing, decreasing, and constant functions. A function is increasing on an open interval if f of x1 is less than f of x2, whenever x1 is less than x2. A function is decreasing on an open interval if f of x1 is greater than f of x2, whenever x1 is less than x2. A function is constant on an open interval if f of x1 equals f of x2 for any x1 and x2. In other words, if you read a graph from left to right, that's what x1 being less than x2 means, the function is increasing for the uphills, decreasing for the downhills, and constant for the flat parts of the graph. We describe where these happen using interval notation. We always use the x-coordinates and never the y-coordinates. So example 1, determine the intervals where the function is increasing, decreasing, and constant. So again, we want to read our graph from left to right. And visually, we're looking for where are the downhills, where are the uphills, and where are the flat parts of the graph. So starting at the left, if I follow along like a roller coaster track, we've got a downhill, and then an uphill, and then a downhill, then it's flat, and then an uphill. So my downhills, where we are decreasing, occurs at starting at here, and we talked about this in the last section, since the graph extends all the way to the edge of the grid system. That is implying that the graph continues off to the left forever. So negative infinity, and we stop decreasing here when x is negative 5. Okay. Decreasing again here, starting at x equals negative 1, and decreasing to here, and that's at x equals 3. And that's the end of our decreasing. So for decreasing, we have the intervals negative infinity and stopping at x equals negative 5. And then also, again, starting at x equals negative 1 and ending when x equals 3. So there's our intervals for decreasing. Again, notice we don't do anything with the y value. These are all x values. And also, we always use parentheses when we describe increasing, decreasing, and constant, not brackets. Looking at our graph again, where are the intervals where we are increasing? Okay, so if we look for the uphills, starting at negative 5 for x, we have an uphill to here at x equals negative 1. And then we have another uphill here, starting at x equals 5, and that one continues on forever. So the increasing parts of our graph starts at x equals negative 5, ends at x equals negative 1, and then again starts at x equals positive 5, and does not end, goes to infinity. The last thing is to identify where our function is constant. So the function is constant when the graph is flat, and that's occurring right here. So that's happening between x equals 3 and x equals 5. So the graph is constant starting at x equals 3, ending at x equals 5.